Modern aircraft depend on hydraulic power to perform demanding mechanical tasks like operating landing gear, brakes, and flight controls. Instead of heavy mechanical linkages, hydraulics use pressurized fluid to multiply force efficiently and reliably. Even a small control input can produce powerful movement. To understand how this works, let's begin with the basic components of an aircraft hydraulic system. Regardless of its design or purpose, every hydraulic system contains a minimum set of essential components. The pump is the heart of the system. It draws hydraulic fluid from the reservoir and forces it into the system under pressure. The reservoir stores the hydraulic fluid. It also allows the fluid to cool and gives trapped air a chance to escape before the fluid is recirculated. To control where the fluid goes, selector or directional control valves are installed. These valves determine which actuator receives hydraulic pressure. The actuator is the working unit of the system. It converts hydraulic pressure into mechanical motion. This motion may extend landing gear, apply brakes, or move a flight control surface. To prevent damage from excessive pressure, a relief valve is installed. If pressure rises above safe limits, the valve opens and returns fluid to the reservoir. Check valves ensure fluid flows in only one direction, preventing backflow. Filters remove contaminants from the hydraulic fluid to protect system components. Together, these parts form the foundation of every aircraft hydraulic system. An open-center hydraulic system is designed so that fluid flows continuously when the system is operating, but pressure does not build up unless a component is being actuated. In this system, the pump circulates fluid from the reservoir through each selector valve in sequence and back to the reservoir. The selector valves are connected in series. This means the pressure line passes through one valve and then the next. As long as no selector valve is activated, fluid flows freely through the system. There is movement of fluid, but no significant pressure. When a selector valve is moved to operate an actuator, the return path to the reservoir is blocked. Fluid is directed into the actuator, and pressure begins to build. This pressure moves the actuator piston. Fluid from the opposite side of the actuator then returns to the reservoir. Depending on the design of the selector valve, the system may require manual return to neutral, or it may automatically return once a preset pressure is reached. One advantage of the open-center system is that it is not continuously pressurized. Pressure builds gradually, which reduces shock and minimizes pressure surges. However, because pressure must build after activation, the system operates slightly slower than other designs. A closed-center hydraulic system operates differently from the open-center design. In this system, hydraulic fluid is under pressure whenever the pump is operating. Unlike the open-center arrangement, the selector valves are connected in parallel rather than in series. This means each actuator has its own separate path from the pressure line. Because the system remains pressurized at all times, the moment a selector valve is moved, hydraulic fluid immediately flows to the actuator. There is no waiting for pressure to build. This allows rapid and precise operation. Another important advantage of the closed-center system is that multiple actuators can operate at the same time. Since the valves are arranged in parallel, one unit can function without interrupting flow to another. Pressure control in a closed-center system depends on the type of pump installed. If a constant delivery pump is used, a pressure regulator maintains the desired system pressure. A relief valve is also installed as a backup safety device in case the regulator fails. If a variable displacement pump is used, pressure is controlled by an internal compensator mechanism. As system pressure approaches normal operating limits, the compensator reduces the pump's output. When normal pressure is reached, the pump output decreases to nearly zero flow. This condition is known as full compensation. Even in this state, a small internal circulation continues within the pump to provide cooling and lubrication. A relief valve remains in the system as an additional safety measure. Because pressure is always available, closed-center systems provide fast response and are widely used in modern aircraft, especially where instantaneous operation is required. The main difference between open-center and closed-center hydraulic systems is how pressure is managed. In an open-center system, fluid flows when idle, but pressure builds only after a selector valve is activated. This provides smooth operation with minimal shock, but response is slightly slower. In a closed center system, pressure is available at all times while the pump is operating. Actuators respond instantly, and multiple units can operate simultaneously. Because aircraft require fast and reliable performance, closed center systems are the most commonly used in modern aviation. In this lesson, we covered the basic components of aircraft hydraulic systems and the key differences between open center and closed center designs. Closed center systems dominate modern aircraft because of their fast and reliable response. Thanks for watching.